Cracks in concrete can occur for many reasons. In most cases, the story begins long before the concrete hardens. Poor quality materials, an improper mix design, inadequate mixing, careless placement, insufficient compaction, or improper curing can all create weakness within the concrete. When even one step is neglected, the quality of the finished concrete is affected. But here is something many people do not realize. Concrete can crack even when everything is done correctly. Changes in temperature, moisture loss, shrinkage, external loads, and the natural behavior of concrete itself can all create stresses that eventually lead to cracking. And that brings us to the most important thing to understand about concrete. It looks like rock, it feels like rock, but it is nothing like rock. Rock is a single material. Concrete is a combination of cement, water, sand, and aggregates, all working together as one. Each ingredient behaves differently. Each reacts differently to moisture, temperature, and stress. And when those forces become greater than what the concrete can resist, the concrete sends a warning. And that warning is a crack. Some cracks are harmless. Some are signs of poor construction. Others may indicate serious structural problems. So in this video, we will explore the minor and major reasons why concrete cracks, what each crack is trying to tell you, and most importantly, how many of these problems can be prevented before they start. So let's get into it. The first main reason for cracks in concrete are excess water in the concrete mix. Concrete does not need much water to achieve maximum strength. But on most residential job sites, workers add extra water to make it easier to pour and spread. Every extra liter of water you add is a liter that will eventually evaporate. And as it leaves, it pulls the concrete apart from within. And this is what we call a shrinkage. A concrete slab can shrink significantly as it dries and cures. That shrinkage does not disappear. It becomes internal stress. And when that stress exceeds the tensile strength of concrete, a crack forms. The water to cement ratio is the single most critical number in your entire mix design. Lower it and your concrete becomes dramatically stronger. Raise it and no amount of curing reinforcement or admixture will fully save it. Going to the second reason, which is rapid drying of concrete. Concrete does not dry, it cures. This is something which is very important for you to remember. The concrete hydration, a reaction process that helps concrete to gain strength, is a chemical reaction, and it needs water to continue for days and even weeks after pouring. If the surface dries out too quickly due to hot weather, wind, or direct sunlight, the outer layer wants to shrink while the inner layer is still wet and resisting. The surface loses that battle and it starts to crack. A slab that is properly cured for 7 days can be significantly stronger and more durable than one left to dry on its own. So curing is not an optional step, it is a structural step. The third reason is that wrong concrete was poured for the job. Concrete comes in different strength grades. A driveway needs different concrete than a column. A basement floor needs different concrete than a roof slab. When wrong grade is used, usually a weaker mix to save cost, the structure carries load it was never designed to handle, and cracks follow. Always verify the concrete grade before pouring begins. Ask your contractor or the ready-mix supplier for the mix design document. If they cannot produce one, that is your first warning sign. The fourth reason is lack of control joints. This is the reason most homeowners never hear about. Concrete will crack, and this is not a flow, it is physics. The engineering solution is not to prevent all cracking, but to control exactly where it happens. Control joints are pre-cut grooves that create planned weak points in the slab. When shrinkage forces build up the concrete cracks along the planned joint instead of randomly across the surface of the structure. So a common rule of thumb is to space control joints at around 24 to 36 times the width of the slab. For a 4-inch slab, that usually means joints every 8 to 12 feet. Most residential contractors skip this or get the spacing wrong, and the random cracks that follow are often avoidable. The fifth reason is compromised raw materials. Aggregate, the sand, and the gravel in concrete carries more responsibility than most people realize. If your aggregate contains clay, silt, organic matter, or other harmful contaminants, it silently attacks the concrete from within. Clay and silt coat the aggregate surface and prevent proper bonding with the cement paste. The organic matter interferes with the main chemical reaction, that is the hydration. So in some aggregates, reactive forms of silica can combine with the alkalis in cement, causing alkali-silica reaction or ASR. This expansion generates internal stresses that eventually crack the concrete. Aggregate should always be tested for silt content, organic impurities, and durability before use. 6. Mix design was never properly done. A proper concrete mix design is not a guess. It is calculated proportion of cement, water, fine aggregate, coarse aggregate, and admixture chosen to achieve a specific strength, workability, and durability. On most small construction sites, nobody does this calculation. Workers use whatever proportion they are familiar with, often by volume using buckets, with no account for the moisture content of the sand or the required compressive strength of the structure. A proper mix design should always specify the water-cement ratio, the target slump value, and the maximum aggregate size and the minimum cement content. If your contractor cannot tell you these 4 numbers, the mix design probably does not exist. 7. Thermal expansion. Concrete expands when it gets hot and contracts when it cools. So in most climates, this happens every single day. Over months and years, these cycles accumulate into significant stress, particularly in large slabs, pavements, and roof structures, which are exposed directly to sunlight. The coefficient of thermal expansion of concrete is approximately 10 microstrain per degree Celsius. A large concrete slab can move surprisingly far during seasonal temperature changes. Without proper expansion joints, that movement eventually finds relief through cracking. So, expansion joints are not optional in large structures, they are essential. 8. Overloading. Every concrete structure is designed for a specific load. A residential driveway is designed for a family car, not a heavy construction vehicle. A floor slab is designed for normal occupancy load, not for storing tons of construction materials. Many residential concrete failures that are blamed on poor quality are actually overloading failures. The concrete did exactly what it was designed to. It was simply asked to carry something it was never designed for. 9. Poor subgrade preparation. The concrete slab is only as good as what sits beneath it. If the subgrade is uneven or poorly compacted, different parts of the slab settle at different rates. So this differential settlement creates bending forces that concrete struggles to resist. And once the concrete is poured, correcting the problem becomes extremely expensive. A minimum compaction of about 95% Proctor density is commonly specified before concrete placement. The 10th reason is incorrect placement of reinforcement. Steel reinforcement works only when it is placed where tensile stresses are expected. In most suspended slabs, reinforcement is placed near the tension zone, which may be near the bottom, top, or both depending on the loading condition and the support arrangement. If reinforcement is misplaced, the concrete loses much of its crack control capability. Beyond position, if the concrete cover over the steel is insufficient, moisture and chlorides reach the reinforcement and start to cause corrosion. Corroded steel expands and cracks the concrete from inside. So this is what causes the rust, stain, splitting cracks commonly seen in older buildings and coastal structures. Concrete does not crack randomly. Every crack has a cause, and almost every cause leaves clues behind. So it all starts before the first truck arrives on site. Your aggregate quality, your mix design, your water-cement ratio, and your curing practices determine whether your structure lasts for decades or develops problems much sooner. Once the concrete is poured, curing becomes your most important responsibility. Skip it or rush it, and you are accelerating the deterioration process. And when cracks do appear, the next step is identifying what type of crack it is. Surface cracking is very different from a structural flexural crack. I have linked a full guide on crack types and repair methods in the description below. If you found this video useful, please share it with someone who is currently building or renovating. Thanks for watching, and see you in the next video.